All right, today we're jumping into something huge, quantum field theory. It's one of the pillars of modern science, right? But what if we've been calling it the wrong thing? We're going to explore this idea that maybe our best picture of reality isn't a theory at all. Maybe it's more like a recipe. So let's just get right to it. Think about this. What if our most advanced, most successful framework for describing, well, everything, from the tiniest particles to the fundamental forces, what if it isn't actually a deep explanation of what reality is? What if it's just a set of instructions? Kind of like a cookbook.
And this is the big idea we're digging into. It comes straight from the source material we're looking at. The argument, and it's a powerful one, is that quantum field theory, QFT for short, it doesn't really act like a theory. It acts like a recipe. And just switching that one letter from a T to an R, well, it completely changes how you have to think about the whole thing.
Okay, so let's really break this down. What's the actual difference we're talking about here? I mean, what separates a theory that truly explains the universe from a recipe that just tells you what to do?
Well, on one side, you've got what we expect from a big fundamental theory, right? We want it to explain the machinery of reality. We want it to tell us the deep fundamental reasons why things work the way they do. But here's the twist. The source material argues that what QFT actually gives us are the mechanisms. It gives us these incredibly precise, step-by-step instructions for how things happen. But it never, ever touches that fundamental why.
And we really need to get clear on these two words, machinery versus mechanism, because they're absolutely crucial to this whole idea. Think of it like this. The machinery is the actual engine of reality. It's the thing that's really running. The mechanism, well, that's just the user manual for the engine. QFT gives us the manual. It tells us which buttons to press, but it never lets us pop the hood and see how the engine actually works. And that brings us right to the heart of the argument. Quantum field theory is, without a doubt, the most successful user manual ever written. I mean, it predicts the results of experiments with absolutely mind-blowing accuracy. But it only does that by giving us the rules, the mechanisms. The actual machinery behind it all, that's left as a total mystery. So you got to be asking, what is this missing machinery then? What are these fundamental ingredients that QFT just throws into its recipe without ever explaining what they are or where they came from? Well, when you get right down to it, the theory basically says the entire universe is made of just two main things. These are the absolute bedrock, the foundational elements it uses to construct everything we see. And what are they? Space-time and fields. That's it. QFT just takes these as a given, like they're just ingredients you pull off the shelf. You can think of space-time as the stage, and the fields are all the actors performing on it. Every single particle, every force in the universe, it's all just a vibration, a little ripple, in one of these fields. But here's the million-dollar question, right? What are they made of? How do they actually work? And this is the question QFT just walks right past. The theory is brilliant at telling us how to use space-time and fields in our math, in our calculations, but it gives us zero machinery, zero explanation for what they are, how they even exist together, or what gives them the ability to change. In the world of QFT, they just exist. Full stop. I mean, when you start listing them out, the list of unexplained fundamentals is just staggering. QFT has no machinery for space-time. It's got nothing for the fields themselves, nothing for what energy fundamentally is, nothing for that super weird connection we call entanglement. And this is a big one, it's got no machinery to explain how energy actually bends space-time to create gravity. These are the deepest questions in physics, and QFT just treats them as given. They're the starting assumptions of the recipe. And all of this leads to a kind of philosophy, a way of working that has made QFT so incredibly powerful, and yet, for some people, so deeply unsatisfying. Yeah, this whole practical approach is kind of famously summed up with the phrase, shut up and calculate, or a little more politely, do not ask why, just calculate. The entire framework, the whole shebang, is built for one thing and one thing only, to spit out a number that perfectly matches what we see in an experiment. Asking why? Well, that's just not part of its job. Its incredible power comes from its principles and its mathematical rules. It gives us the exact mechanisms, the equations that tell us precisely how a field is going to change, how it's going to ripple, and how it's going to interact with other fields. The recipe itself is basically flawless. It works every time, even if we have no clue what the ingredients actually are. And get this,
Even something as deep and philosophical as chance or probability, inside this framework, it's just another tool in the toolbox. It's a mechanism, a calculator, that you use to get the right answer. It's not trying to explain what randomness is, it's just another step in the recipe to predict what's going to happen. So, okay, if QFT isn't this deep theory about the machinery of reality, then what on earth is it? Well, this last part gets into a pretty radical answer to that question. For what, almost a century now, physicists have been arguing about what quantum mechanics actually means. I'm sure you've heard of some of these different interpretations, things like the Copenhagen interpretation or the many worlds idea. And really, all of these are just attempts to guess at the machinery, to figure out what's going on behind the scenes of the quantum recipe.
But here's where our source material drops a bombshell. It makes this stunning claim. Maybe we don't need an interpretation for QFT, because QFT is the interpretation. The fact that it's just a predictive recipe, that's not a bug, it's a feature. That's not a flaw we need to fix. That is the entire point of the theory.
When you think about it, maybe we've been looking at this all wrong. Maybe we've been judging a cookbook by the standards you'd use for a philosophy book. QFT's purpose was never to answer the why question. Its one and only job was to give us the most perfect, the most precise, the most unbelievably effective recipe ever created for predicting how the universe works. And on that front, wow, it has succeeded beyond anyone's wildest dreams. And that leaves us with this one last, really fascinating question to chew on. If you have a recipe that makes a perfect meal every single time, without ever failing, do you really need to understand the molecular chemistry of what's happening in the oven? Is a perfect prediction more valuable than a deep explanation? Now that's a question that not even quantum field theory has a recipe for. Thanks for joining me.